All right, so today we're going to be talking about simplifying radicals. A radical is just kind of that square root symbol, but they are not all square roots. There can be cubed roots, quartic roots, pretty much anything past a 3 though. Usually you'll say fourth root, fifth root, and on and on and on. So we're going to be talking about how to simplify statements that have these radicals within them. One thing to pay attention to is the index. These numbers that I've written in that top little left portion, those are called the index, and they're going to tell us to what degree that root is. When you don't see a number there, it is because the number is 2. Okay, so it's a square root. All right, in this first one, we're going to just be simplifying here. So my first step is a prime factorization, most specifically of the numbers that you see there. So I'm going to take 216, and I know two factors of 216 would be 8 and 27. 8 can be broken up into 4 and 2, and 4 can be broken up into 2 and 2. 27 is a 3 and a 9, and 9 can be broken up into 3 and 3. So all these numbers at the bottom of that tree, those are the prime numbers that make it up. So the prime factorization of 216, we had 3 2's and we had 3 3's. So 216 is equal to 2 to the power of 3 multiplied by 3 to the power of 3. Okay, now what we're going to do down here in step 2, it says match the index of the radical to the groups. We're going to create groupings of all of our numbers, and we want it to match the index. Remember, when you don't see what the index is, it's because it's a 2. So I'm going to write my square root. Now I'm going to change the 216. Now I could write it as 2 to the power of 3, 3 to the power of 3, like it was up there, but I'm really trying to create squareds. I want the groupings to match the index. So I'm going to have 2 to the power of 2 times by a 2. So I still have 3 2's, but now I've got one of them as a squared, multiplied by a 3 squared times 3. And now with that x to the power of 5 up above, I'm going to create an x squared, another x squared. So there's 4 x's, and I have 1 left over. And then for the y's, y squared, y squared, y squared, y squared. Okay, so that's what we mean by match the index to the groupings. So I've created as many groups of 2, which matches our index of 2, as I could. So now, the way we're going to deal with this is largely the way we deal with something like square root of 3 squared. Now, 3 squared is a 9. The square root of 9 is 3. In other words, a square and a square root eliminate, leaving you with just that number. Now, had this been square root of 3 squared x, well, the x didn't get taken out, only the number that had the square root, so I'd be left with 3 square root x. And that's essentially what we're going to do with everything up above here. Everything that has a squared, we're going to take it outside of the radical. So first we've got that 2, then we've got a 3, then we had 2 x's, we had 4 y's that were in there, and now inside of your radical, everything that we weren't able to take out, everything that didn't have an exponent of 2. So we had a 2, we had a 3, and we had 1x. All right, our final step is just going to simplify by multiplying. So 2 times 3 is 6, X times x is x squared. And we had 4 y's, so y to the power of 4, square root. 2 times 3 is 6. And there was an x there. And that is the full process of simplifying that radical. Okay, we're going to repeat the process again. Now, this time with a 176, okay, which can be separated out into 16 times by 11. 16 can turn into a 4 times a 4. And each 4 gets separated out into 2 2's. So 176 is 2 to the power of 4 multiplied by 11. All right, so now as I start writing this root, so root 4, 176, we are now changing that to 2 to the power of 4 times by 11. Then we have x cubed y to the power of 6. Oh, and actually in this step 2, I do want to make one little change. So I'm going to make my change to the y to the power of 6. I want to make my index match the radicals. So I want everything I can to get to the power of 4. Well, we have 6 y's, so I can make one group of 4 and one group of 2. Now, everything that's been put into a group of 4, we can now take out. So that 2, that's right there, we can bring that out of the radical. The 11 stays in, the x stays in, the y to a power of 4 can come out. And then on the inside of our radical, the 11 had to stay in, the x cubed had to stay in, the y squared had to stay in. There's nothing really to multiply, so that one's done. That's as far as we can simplify it. Okay, in this next one, we're going to talk about adding and subtracting. Now, the first step in adding and subtracting these is, hopefully that looks familiar. It's essentially, we're going to start off with simplifying. We're going to begin by simplifying each one of those statements and then seeing if we have any like terms. So first, let's start off writing the 2x squared. Prime factorization of 18 is going to be 3 squared times by 2. And I've got xy cubed plus 4y square root. The prime factorization of 8 is 2 cubed, x to the power of 5y, minus 3. Prime factorization of 75 is 5 squared times 3, x cubed, y squared. So notice all I did is I changed the numbers inside the radicals to their prime factorizations. Next, I'm going to match the index to the radicals in the groups. Each of these was a square root, so I want to create groups of 2 inside there. So let's see, we already had 3 squared. That works out well. Times 2x. We had a y cubed up above, so I'm going to change that to y squared y. So I did create that group of 2 that I'll be able to take out. Plus 4y square root. That 2 cubed, we're going to change it to 2 squared times 2. The x to the power of 5 will change into x squared times x with a y minus 3 square root 5 squared times 3. The x to the power of 3, we're going to change it to an x squared times x and a y squared. All right, so now I've created as many groups of 2 that can be pulled out of that square root as possible. So now we're going to begin the process of moving them out. So 2x squared. Then on the inside, we can take out the 3, and we can take out the y. Okay, so the 3 came out, and that y came out. Then what's left on the inside is we had a 2, and x, and a y. Okay, plus 4y, and then we're going to have a 2 come out, an x come out, another x come out, and then what's going to stay inside there is a 2, an x, and a y. Okay, and so we see that's where all of those came from. Next, minus 3, and we can have a 5 come out, an x come out, and a y come out. And we're going to be left with a 3 and an x on the inside. Okay, so now simplifying, we can just start multiplying things. So we've got a 2 and a 3, so we'll have 6 x squared y square root 2xy plus 4 times 2 should be 8. There were 2 x's there, so x squared y square root 2xy minus 3 times 5 is 15 xy square root 3x. Now, in order to combine things like terms, all the variables have to be the same, and not just that it has to be the same letter, but it needs to have the exact same exponent. So you'll notice right here in this third term right here, even though the other two had an x squared, that one just has a normal x, just an x to the power of 1. We cannot combine this minus 15 with these other ones because they are not the same. There's one other thing that makes it the same, or that makes that one different. Everything inside of the radical needs to be the same. And once again, that third one, just slightly different. So I will not be able to combine the like terms with the third one. But this first one, both of them have x squared y square root 2xy's. So just like adding a 6x plus an 8x and getting 14x, we're essentially just doing 6 of this plus 8 of this, and it's the same in both, and we get 14 of that particular expression. Then we'll tag on the minus 15 xy square root 3x. Okay. All right, next we're going to talk about multiplying. Now with addition, notice we simplified first, and then we found out what the like terms were that we could combine. When you're dealing with multiplication, you're going to multiply first, and then you can figure out what the what will simplify. Now, as you're multiplying, we've got numbers that are outside of radicals, and then we've also got numbers that are inside of radicals. The numbers that are outside of radicals are going to multiply to the numbers that are outside of radicals. So outside to outside, inside to inside. But both things in the term need to get multiplied. And we are going to use distributive property to multiply it to both. So first, my two things in purple, the things that are outside of radicals, 3 times 3x will give me 9x. But I also had that square root 15. It doesn't really have anything to multiply by, so it just says square root 15x. Okay, now we can put plus. The 3 can be multiplied by the invisible 1 we'd say it was there, and we'd get a 3. And now square root 15x times square root 5x, we can just multiply those things that are inside. So 15 times 5 is a 75, x times x, x squared. Now that we've done that step in the multiplication, we can start doing prime factorizations to see if there's anything that will simplify. So 75 is 5 squared times 3. So we do see some squareds that we're going to be able to take out. So now in this next step, I'm just going to take everything inside square roots that has a group of 2, and we'll take it out. And then anything that didn't have a square, and that'll stay inside. Okay. Finally, we're just going to go ahead and simplify with our multiplication. So 15x plus 15x square root 3. And there we are. Okay, I hope this helps. Good luck on your assignment.